Hello class, welcome to Geometry Lesson 5.4, which is all about inequalities in one triangle. By the end of this lesson, you should be able to use theorems to compare the sides and angles of a triangle. So let's start out with example 1 by investigating side and angle relationships. We want to figure out which angle measure appears to be the smallest in the triangle, and then how is it related to the side lengths. So if we look, the angle that looks to be the smallest would be this angle right here, right? And if I look, that angle is opposite of this side. This side is 8 feet long. My side lengths are 8 feet, 23, and 26 feet. So notice how the smallest angle is opposite the smallest side. Another thing we could say is the largest angle would be opposite the largest side. Okay, so that is something that is always true in a triangle. The largest side is opposite the largest angle. The largest angle is opposite the largest side. Same thing goes for the smallest sides and angles. Now, Theorem 5.9 is talking about if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So that means if we have a scalene triangle or a triangle with 3 different side lengths, then this is true. Okay, so that's what I was just describing on the last slide. Now, let's use that theorem. So in order to support a triangular piece on a float, a brace is placed at the largest angle and a guide wire is placed at the smallest angle. Which angle is the largest and which angle is the smallest? So if I look at that float, I see I have side lengths 10, 12, and 13. So my largest angle is going to be opposite my largest side. My largest side is 13. So that means that my largest angle is angle C. Then if I'm looking for my smallest angle, my smallest side is 10 feet. That means my smallest angle is opposite that, which would be angle B. So my smallest angle would be angle B. And that is all that it's really asking there. Okay, I want you to look at this diagram and determine what angle is the largest angle, and then what angle is the smallest angle. Good luck. Hopefully you said angle E is the largest angle and angle D is the smallest angle. If you have questions about that, please be sure to reach out for some help. All right, Theorem 5.10 is basically the same as 5.9, but this time we're talking about side lengths. If angle B is bigger than angle A, then the side across from B has to be bigger than the side across from angle A. So, example 3, if we look at the angle-side relationship, so which side of the triangle is the longest? So the way that I would look at this is that first I need to know what all 3 of the angle measures are. I know there's 180 degrees in the triangle, so if I subtract 62 and 50 from 180, I'm left with 68 degrees for that last angle, and I want to figure out which side of the triangle is the longest. So I can say angle K, opposite of angle K is little k, opposite of angle M, I'm going to do a little m, opposite angle L, I'm going to do a little l. So side, which side would be the longest? That would be the side opposite my biggest angle. My biggest angle is 68 degrees, so that means that side K would be the longest side. Go ahead and look at this triangle and determine which side is the shortest. Good luck. Hopefully for this one you said side NP, or maybe you called it little o, like I did on the last ones. Both of those could be correct, but it would be this side right here because it's opposite our smallest side, which is 57, or smallest angle, which is 57 degrees. Theorem 511 is the Triangle Inequality Theorem. So that means that the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. And I'll show you exactly what that means with these, this next one. So we want to use that Triangle Inequality Theorem. So I want to see which of the following sets of segments could be the sides of a triangle. So if I say 18 plus 19, I just picked two sides. Those two sides have to be greater than my third side. So is 18 plus 19 greater than 40? No, that is saying 37 is greater than 40, which is not true. So these three sides can't form a triangle. Now let's try this one. If I do 33 and 37, those two sides should be greater than my third side. So 33 plus 37 is 70. Is 70 greater than 66? Yes. Okay, so then I can say 33 plus 66 has to be greater than 37, which that is true. And then I have to test the last one and say 37 plus 66 is greater than 33, which is also true. So those three sides could make a triangle. So if I look, this is what would happen. You see, if I had 18 and 19 over on the left, those aren't long enough to make a triangle. I would have to adjust this, in which case this would no longer be 40. So those three sides can't make a triangle. If you look at the one on the right, 33, 37, and 66 can make a triangle. So then we have a triangle has sides that measure 11 centimeters and 16 centimeters. We want to find the possible lengths of the third side. So if we are trying to figure that out, we know that any two sides have to be greater than the third side. So I could take x plus 11, and that has to be greater than 16. And I could do x plus 16, that has to be greater than 11. And if I did 11 plus 16, that has to be greater than x. So if I start with this first one right here, in order to solve that, x would have to be greater than 5, right? I'd subtract 11 from both sides. Okay. Then the second one, 11 plus 16 is greater than 11. If I solve that, I get x is greater than negative 5. Can I have a negative value? I can't have a negative 5 for a side length. So I'm going to throw that one out. And then if I look at the last one, 11 plus 16 is greater than x. That'd be 27 is greater than x, or x is less than 27 is one way that you could read that. So I know that x has to be greater than 5, but also less than 27. So my third side can be any number between 5 and 27. Okay, so that might have seemed more complicated than it is. So let me talk through that again with fewer words in the middle. The way that you can solve these is if you do the sum of the two sides that you know, that's going to give you your upper end typically. And then if you subtract your smaller side from your bigger side, that's going to give you the smaller end, okay? So that is how you can find that range of values. Why don't you go ahead and look at this question. We have a triangle has side lengths that are 30 inches and 50 inches. Okay, so if I draw a triangle, 30, 50. I know that doesn't represent what 30 and 50 would look like. It's just a sketch to help me keep track of my information. what are the possible lengths for the third side? And I want you to write it as an inequality just like I did on the last one. Good luck. Hopefully you ended up with x being a value between 20 and 80. So 20 is less than x is less than 80 is how you would write that inequality. And here is the concept summary for this lesson. So just remember the biggest side is opposite the largest angle, and the biggest angle is opposite the largest side. Same thing goes for smallest. And then the triangle inequality theorem, any two sides added together have to be bigger than the third side. If you have any questions at all, please be sure to reach out for some help, and I would be happy to help you. Have a great day.